Good morning, learners once more. This is our fourth session. I hope you are feeling prepared and confident as the final examination approaches. Once more, my name is Dr S Kodisang, and today we are going to explore the Theorem of Pythagoras together. I'm really excited to guide you through this lesson and help you see how it can make solving problems easier and even fun. Now, we are expected to investigate the relationship between the lengths of the sides of a right-angled triangle to develop the Theorem of Pythagoras. Meaning we are going to get an understanding what is all about the Theorem of Pythagoras. And we are also expected to determine whether a triangle is right-angled or not, if the lengths of the three sides of the same triangle are known. And lastly, we are also expected to use the Theorem of Pythagoras to calculate a missing length in a right-angled triangle, leaving irrational answers in set form. So this is the expectation in grade 8. Now, because we are going to deal with triangles or triangular shapes, these shapes are all around us in everyday life, often providing strength, stability, and practical use. For example, the design of wheelchair ramps often relies on triangular structures to ensure safe and steady support. The triangular form can also be noticed in the way doors are reinforced at the corners. You can see the door there is an aluminum door, giving them strength to stand upright. Even in furniture like tables, you can see the table also. Triangular shapes help maintain balance and prevent wobbling. Beyond construction and design, triangles are also useful in problem solving. For instance, by applying simple geometric principles, one can use triangular shapes to measure the height of a tree without climbing the tree. By creating a right-angled triangle with the tree, the ground, and a measuring tool, this shows how triangular shapes are not only common in our surroundings, but also available in practical application. Now, the very important thing, or the first thing that we need to remind ourselves of is the issue of the kinds of triangles that we need to know as learners. But I believe you did this in lower grades or in previous grades. Now let's quickly look at the types of triangles that are known to us. The first one is a scalene triangle. Now this triangle, why a scalene, is because no sides are equal in length. As you can look at the first triangle, triangle ABC, it has markings. AB has only one marking, BC has 2 markings, and AC has 3 markings. Because it doesn't have equal markings, it means the sides are not equal in length. That must be very clear. Now again, with a scalene triangle, no equal angles. You can see with angle A, there are 3 markings, angle B, only 1 marking, and angle C has 2 markings. Because the markings are not the same, they are not equal, it means this is a scalene triangle. So meaning that you can describe this kind of a triangle by mere looking at the markings on the sides of the triangle or the angles in this particular triangle. if the angles are not equal, then you immediately conclude that it's a scaling triangle. Now the second example is an isosceles triangle. It has two sides of equal length. When you look at that triangle, is triangle AOB. AO is equal to AB. And the third side, which is OB, is called the base. Now in an isosceles triangle, only two sides are of equal length. So you can see AO is equal to AB. One marking on AO and one marking also on AB. So this is how you name the angles. You can either say angle AOB or angle O, or angle ABO or angle B, and the last one angle BAO or angle A. So this is how we name the angles, right? And before I move to the right-angled triangle, I want to emphasize that naming and labeling triangles are important because they help us communicate clearly and work accurately when solving mathematical or real-life problems. When each vertex or a corner of a triangle is given a name, it becomes easy to identify specific sides and angles. This prevents confusion, especially when dealing with more than one triangle in a diagram. Proper labeling also allows us to apply geometric rules correctly. In practical settings like construction, engineering, or design, accurate labeling ensures that measurements and instructions are followed precisely. In short, naming and labeling triangles provide clarity, precision, and consistency in both learning and real-world application. Now, the third type of a triangle is a right-angled triangle. Why are we saying this is a right-angled triangle? Is because it has an angle of 90 degrees, right? Now, in a right angle, the hypotenuse is the side opposite the right angle and is the longest side of the triangle. Let's look at triangle ABC again. The longest side in this case is AB, and AB is called the hypotenuse. So every time when we solve problems related to the right angle triangle, we need to make mention of which one is the hypotenuse and which ones are the other sides. So the side that is always opposite the right angle, which is angle C in this case, is a hypotenuse. So we only apply the theorem of Pythagoras when we deal with the right angled triangles. The first mathematician to identify the connection between the sides of a right-angled triangle established what is now known as the Theorem of Pythagoras, or the Pythagorean theorem, right? His most renowned mathematical achievement is this particular theorem. You can see that this is only applicable in a right-angled triangle. Now, let us now see how Pythagoras identified the connections between the sides of a right-angled triangle. I remember when I was in grade 8, I memorized this theorem without a clear understanding of its underlying meaning. Now, let's quickly look at what it actually means. What Pythagoras did, he introduced, let's look at figure 2. He introduced the square on each side of the right-angled triangle. Now, the side or the hypotenuse is C, side C, and the other side is A, and the next side is B. So remember, we said in a triangle we have three sides. In this case, side A, side B, side C. So what Pythagoras did, he introduced the square on each side of a triangle. So when you look at side C, it has 25 squares, right? Side A has 9 squares and side B has 16 squares. Now, when you count the total number of small squares on the big square C, the small squares are 25, as I have indicated. The small squares on square A, they are 9, and then on square B, they are 16. Now, what is the relationship? When you look at the small squares that are in square C and the small squares that are in both square A and square B, when you add the small squares from square A and square B, their sum will always amount to the number of squares that are in square C. Hence, this theorem of Pythagoras to say the sum of the area of square C, the sum of the area of square A and square B is equal to the area of square C. The sum of the area of square A and square B is equal to the area of square B. So that is the theorem of Pythagoras. Now, if I want to state it clearly, it says, the theorem says, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So that is the theorem of Pythagoras. I think it's very clear. You understand the meaning in terms of the area. You understand the meaning in terms of the small squares. So the area indeed of a two-dimensional shape like a triangle here refers to the amount of space enclosed within the boundaries of that particular shape. Right. Other important points to consider as a learner is accuracy in measurement and calculation. What does it mean? It means as a learner you need to ensure that you interpret the given information correctly, label size clearly, and carry out calculations precisely to avoid errors in determining the lengths. And also careful interpretation of diagrams and given information, meaning that you should pay attention to what is provided in the problem, label diagrams clearly, and avoid assumptions about lengths or angles that are not stated or proven. The last one, units of measurement. We are dealing with the dimensions here. These units provide precision and clarity to numerical values. They ensure consistency in calculations, enable accurate comparisons, and prevent errors that may arise from misinterpretation or incorrect conversions. Right, solving geometric problems to find unknown sides and angles. Remember, the theorem of Pythagoras is assisting us to solve the unknown side of a right-angled triangle. You need to know that solving geometric problems is an opportunity to practice solving equations, meaning you need to make sure that you are able to solve the linear equations before you can be able to determine the other side of the right-angled triangle. It is important to understand also that the theorem of Pythagoras applies only to right-angled triangles. I think I have already alluded to that. The theorem of Pythagoras is basically a formula to calculate the unknown length of sides in a right-angled triangle. So this is very, very important learners. Now let's see how best can we apply the theorem of Pythagoras. Using the theorem of Pythagoras to determine the third side. Remember, I've already indicated that a triangle has 3 sides, hence the word tri. Tri pertains to 3. So from that diagram, you could see that the hypotenuse is C. Now to get the value of C, we need to always write that equation that shows the areas according to Pythagoras theorem to say a squared plus b squared is equal to c squared. So we have to substitute a by 3, b by 4 to get the value of c. Now a squared is the same as 3 squared and b squared 4 squared. That is equal to c squared, or the sum is equal to or is the same as c squared. Now 3 squared is 9, 4 squared is 16, 9 plus 16 is equal to 25. And on the right hand side we have c squared. This is the application of the theorem of Pythagoras. To find the value of c, remember, we need to introduce the set sign, the square root of 25, and we know that the square root of 25 is 5. So the value of c obviously will be 5. Now there's a question on the side to say, could you point out the mistake or the omission in this answer? Yes, of course, because we are dealing with the dimensions. The omission from this solution is the fact that the unit of measurement is not included. So the correct answer in this case should be 5 centimeters. Now, another important thing is we need also to be aware of the Pythagorean triples. Pythagorean triples are sets of 3 numbers that can form the sides of a right-angled triangle. These numbers satisfy the Pythagorean theorem, or the theorem of Pythagoras, which states that the square of the hypotenuse, which is the longest side, is equal to the sum of the squares of the other 2 sides. So these are the Pythagorean triples. So we need to check as to whether if we are given 3 numbers, do they really qualify to be Pythagorean triples or not? Now let's quickly look at the solutions. Number A, we are given 3, 4, 5 as the 3 numbers. For G, we have 6, 13, and 14. And for F, we have 11, 60, and 61. Let's start with the first one. I still want to emphasize, learners, that once you are working with the theorem of Pythagoras, this formula is very, very key. A squared plus b squared is equal to c squared. And we have learned that the big number is always or represents the hypotenuse. So A will be substituted by 3, and then B by 4. C, obviously, since it's the longest side, it will be by 5. So 3 squared is 9, 4 squared is 16, and 5 squared is 25. To add the 2 numbers on the left hand side, the sum is 25, which is exactly the same as c squared. Now, because the left hand side is the same as the right hand side, we immediately conclude by saying the numbers satisfy the Pythagorean theorem, or the theorem of Pythagoras. Let's move to number 2. A should be substituted by 6, B by 13, and C by 14, because that is the longest side. C squared is 36, 13 squared is 169, and 14 squared is 196. Now, when you add the 2 numbers on the left hand side, they give you a sum of 205, and on the right hand side is 196. So the left hand side is not equal to the right hand side, meaning that the numbers do not satisfy the Pythagorean triples. So you cannot conclude that these numbers are the dimensions of a right-angled triangle. Now on F, we are given 11, 60, and 61. A is replaced by 11, and B A is replaced by 60 and C by 61. What is 11 squared is 121. 60 squared is 3,600 and 61 squared is 3,721. So when we add the left hand side, we realize that the sum is 3721 or 3,721. That is the correct way of saying a number is equal to 3,721. So we therefore conclude by saying the numbers satisfy the Pythagorean theorem because the left hand side is equal to the right hand side. Now in activity number 2, we are expected to determine whether figure P as given there is a right-angled triangle or not. And then secondly, we are expected to calculate the values of A and B in figures Q and R respectively. So let us quickly look at the solutions of the 3 questions. Figure P, we are given the 3 numbers. So we need to check as to whether these numbers satisfy the Pythagorean theorem. Right, we substitute A by 6, B by 11, and then C by 13. When we simplify, we realize that 6 squared is equal to 36, 11 squared 121, and when we add the 2, they give us the sum of 157. And on the right hand side, we've got 169, and we immediately, because the 2 sides are not equal, the numbers do not satisfy the Pythagorean theorem or the theorem of Pythagoras. Now let's look at number 2. Number 2 and number 3 is a different question in this case, in the sense that you need to calculate the third side. You are given 7, you are given B, you are given 8, right? 8 is the hypotenuse if you look at the diagram figure R. 7 is one side and B is the other side. Now, very important again, make sure that you write down the formula A squared plus B squared is equal to C squared. But this time we are given the hypotenuse on one side. It means we need to get the other side. And remember, I indicated earlier on to say you need to know how to solve the equations. Right, 7 is substituted by 49. 7 squared is equal to 49, and B squared will remain B squared because we are looking for the dimension of B, and then A squared is 64. So to solve this equation is very important to introduce the additive inverses. Now the additive inverse of 49 obviously will be negative 49. So 49 plus negative 49 is the same as saying 49 minus 49, and that will give you 0. So B squared will remain, and 64 plus negative 49 is the same as 64 minus 49, for which the difference in this case is 15. So B squared is equal to 15. But we are not interested in B squared, we have to find B. And to find B, we need to introduce the set square or the square root. Therefore, the value of B will be the square root of 15. In grade 8, you are expected to leave the answer in set form. The set form in this case is the square root of 15. But in grade 9, you can further leave the answer as a decimal fraction. Hence, I said this is approximately 3.87. It's not an approximate number, but we rounded off the number to 2 decimal places. You may give your answer in set form, as I've already indicated, or leaving irrational answers in set form, or as a decimal fraction. Figure Q, the same thing. We're applying the same rule. Have the equation ready. A squared plus B squared is equal to 8 squared and 4 squared is 16. You add this to a negative 16, which is the additive inverse of 16, plus a squared is equal to 64. So what you did on the left hand side must also be done on the right hand side. You have introduced negative 16 on the left hand side. It's important also to introduce the negative 16 on the right hand side. So a squared is equal to 64 minus 16, for which the difference in this case is 48. So a squared is 48, but we are not interested in the value of a squared. We need to get the value of a. In this case, it will be the square root of 48. So for grade 8, you leave it at the square root of 48, but further on, you need to approximate it to a decimal fraction, which is 6,93. So those are the solutions for the 3 problems. Now the activity number 3, solving problems using the theorem of Pythagoras. Okay, let's move to the next slide. Examples of solving problems using the theorem of Pythagoras. In triangle ABC, angle B is 90 degrees. It's illustrated there. It's important to use figures. Represent the word problem by using figures or tables. This will make your life very much easier. Angle B is 90 degrees. AC is 4 centimeters. It's a hypotenuse. We can see BC is 2 centimeters. Calculate the length of AB without using a calculator and leave the answer in the simplest set form. So the first thing that you have to do is to write the equation. A squared plus b squared is equal to c squared. So in this case, it will be ab squared plus 2 centimeters all squared is equal to 4 squared. And the ultimate answer should be the square root of 12, which is approximately 3,46. I urge you to verify these calculations. Sometimes you might find that there are typing errors, but the square root of 12 is approximately 3,46. Remember, one of the issues that I have talked to is the fact that you can apply the theorem of Pythagoras in our everyday life. For instance, this problem says an 11-meter ladder is leaned up against a wall. The base of the ladder is placed 4 meters from the wall. How far up the wall will the ladder reach? So looking at this problem, you can see from far that this qualifies to be a right-angled triangle. Your ladder will be the hypotenuse, and the distance from the bottom of the ladder to the bottom of the wall will be 4 meters, and x will be the height of the wall. Now to get the size of x, or the height of the wall, you need to also apply the theorem of Pythagoras. You start by writing the equation a squared plus b squared is equal to c squared. In this case, the c squared will be 11 squared, and the a squared will be 4 squared, and the x squared will be the other side. So you have to write that equation and find the value of x. You need to introduce the additive inverses for you to be able to answer this question, but ultimately the value of x will be the square root of 105, which is approximately 10.25. Please verify the calculations again. Right, now another question is, which of the following triangles is suitable for applying the Pythagoras theorem? And you need to justify. Obvious is number C, because the angle of 90 degrees is denoted as such in the third triangle. And when you look at triangles A and B, all the angles are less than 90 degrees. So the correct answer will be C. For each of the triangles shown below, write the corresponding Pythagoras theorem formula. The first things first, identify the hypotenuse. The hypotenuse is represented by the letter A capital letter A, and the other two sides are represented by capital letter B as well as capital letter C. Now the equation in this case will be C squared plus B squared, or B squared plus C squared, is equal to, the sum is equal to A squared, because the hypotenuse is A. For number B, the hypotenuse is H. The equation will be H squared is equal to R squared plus L squared. For number C, X squared is equal to Y squared plus Z squared. And the last one, which is D, N squared is equal to M squared plus P squared. So the equation that represents the theorem of Pythagoras is very, very important. Now with this one, you are expected to find the missing values. Obviously, that will be the hypotenuse. First things first, write the equation. A squared for number A will be capital letter A squared is equal to B squared plus C squared, and you substitute those dimensions. Same thing applies to number B. H squared is equal to R squared plus L squared, and you substitute the numbers. Remember to leave your answer in set form in grade 8, but from grade 9 upwards, you can still round off the decimal fractions into 2 decimal numbers. And this is the last one. Use the Pythagoras theorem to determine whether the triangle is right angled or not. The longest side is a hypotenuse. What you have to do, you look at A, you look at B, you also look at C. A is 26 centimeters, B is 33 centimeters, and C is 40 centimeters. You can guess from here that the longest side obviously will be a side with a dimension of 40 centimeters. Then it immediately tells you that the hypotenuse is 40 centimeters. So to determine as to whether the triangle is right angled or not, we need to check as to whether A squared plus B squared, the sum of the two is equal to 40 all squared. If the left hand side is the same as the right hand side, then you immediately conclude that the dimensions satisfy the theorem of Pythagoras and they qualify to form a right angled triangle. Yeah, it has been a truly rewarding experience for me, learners, to engage with you. I hope you have discovered not just how to solve problems, but also the joy of understanding the ideas behind these problems. I want to indicate that mathematics is all about learning the principles, applying them in different ways, and uncovering the golden rules that make problem solving so exciting. And remember, the secret to become really good at mathematics is constant practice. Practice, 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 practice. As you prepare for your upcoming exam, stay confident and give your best. I know each of you has the ability to succeed. I can't wait to see you again in 2026, ready to take on grade 9 with even more curiosity and enthusiasm. Keep believing in yourself. Just tell yourself that I'm going to make it. I will make it. Nothing is impossible. Keep practicing and keep exploring. On that note, I just want to say thank you very much for listening to me. All the best going forward. Thank you.